Good morning, everybody. We welcome you to the second day of the conference on Quantum Physics and Madhyamaka Philosophical View, organized by Jawaharlal Nehru University and co-sponsored by the Dalai Lama Trust. We begin today's program with a book release, where two books will be released by His Holiness, followed by the presentation of an edited book to His Holiness the Dalai Lama. For the first book release, I would like to request the Ambassador, T.P. Srinivasan, to give us a welcome note and to introduce us to his book, and then present the book to His Holiness the Dalai Lama.
Your Holiness, Mrs. Venkateswaran, Mrs. Kalpana Peck, Publisher Sri K.R.P.R. Nair, distinguished guests. Today, we are basking in the glory of His Holiness' love, affection, and regard for Ambassador A.P. Venkateswaran. Without those sentiments from His Holiness, we would not have been able to share this very precious moment when he will release a book on Ambassador Venkateswaran to the world. The book has already made history in the sense that this is the first book of this kind which celebrates the life and work of a former Foreign Secretary of India. He has a special place in the history of Indian foreign policy, and even more, he has a special place in the hearts and minds of his colleagues and anyone who has met him. I heartily welcome His Holiness the Dalai Lama to our midst. The fact that he is releasing this book has made it even more historic because of his affection and friendship with Ambassador Venkateswaran. Friends, this book is basically a compilation of the many tributes, spontaneous tributes paid to Ambassador Venkateswaran when he passed away last year. This also contains several articles which were written specifically for the book. The addition in it, the inclusion in it of the so far unpublished oral history of Ambassador Venkateswaran, recorded by Ambassador Kishan Rana, has embellished the book even further. This is by courtesy of the Ministry of External Affairs and the Council for World Affairs, ICWA. We, Jim Peck, Ambassador Venkateswaran's son-in-law, and I myself, compiled and edited this book from two corners of the globe, he in the United States and I in India. The book has been a labor of love for all of us, the contributors, the family, the editors, as well as the publisher. The book has already received warm welcome from the public and already received several favorable reviews. The fact that Ambassador Venkateswaran's thoughts on various foreign policy issues have been published for the first time has been noted by strategists, thinkers, and general readers. So we have this unique moment when the book will be released by the lotus hands of His Holiness. I'm sure that the Delhi public will receive it warmth because this is a city where Ambassador Venkateswaran lived the best part of his life and also made a significant contribution to the foreign policy of India. So may I welcome you all once again and request Kalpana and Sri Nair to hand over the book to His Holiness. May I request Ambassador S.J. Singh to come up and receive the book from His Holiness. May I request His Holiness to hand over the book to Ambassador S.J. Singh. Thank you very much, Mr. Venkateshwaran. Now may I request His Holiness to say a few words.
It is difficult to pronounce that name, Kasai.
Mr. Venkateshwar.
Firstly, you see, my computer here, very difficult to keep name. But meaning, philosophical views, yes, this computer is quite useful. So therefore, firstly, I think one reason, because it's really difficult to pronounce different name, and then rank these, I do not much sort of interest. So I always use brothers, sisters. It is much easier. Then secondly, of course, we are human brothers, sisters. It is true. Different name, different position, different religion is secondary. I think a lot of problems which we are facing today is with too much sort of emphasis, secondary level of differences. If you go deeper level, human level, hardly, you see, no reason to kill each other. So in any way, so this, see, late, my great friend, since many years, you see, he was one person. Sometimes I can complain something. So he advised me and give me encouragement to keep, you see, my sort of the enthusiasm. See, really, very wonderful. Whether you see in the book, whether mentioned or not, when we met, you see, a quite frank discussion about the government policy or these things. So he's really a wonderful person. And his mind, very sharp, very sharp. Of course, I think you know better as a wife, Marbe, a daughter. In any way, so just other day, I participate the award in the name of late President Kasa, former President
APJ Abdul Kalam.
Abdul Kalam. So there also I mentioned the person no longer with us, but their spirit still remain. So as a Buddhist, Nagarjuna, even Buddha himself, no longer with us. But their views, their theories, you see, their teachings, still, you see, very much alive. So similarly, you see, these great personalities, great sort of human being, physically, there is limitation. Their life, limitation. But their sort of also the result of their work, and also their spirit will remain. So, book, immense help, you see, to know, because of the more people, more people, and that's the way to keep their inner strength and more holistic views. It's wonderful. Again, you see many problems. Lack of holistic. Just to look one point. That's, you see, sometimes create problem. Because, in order to know the reality, as we already discussed, interdependency, relevant in many factors. Unless you know all these factors, you see, you cannot see the reality. Without knowing fully about the reality, then your effort, no matter how sincere motivation, but effort become unrealistic because lack of knowing the reality. In order to know the reality, you have to look from all kasota.
From wider perspective.
Wider perspective, or one dimension you can't see, 4 dimensions, 6 dimensions need to know the reality. So these great, sort of the experienced persons sort of thinking, they are sort of word, I think, very, very useful. So firstly, as a human being, I want to thank. Then secondly, I'm great admirer or great friend of that late person. So on that level, I want to thank. Thank you. So then please buy, the audience, buy that book and read.
Thank you very much, Your Holiness, for your very gracious words. I might inform you that the letter that His Holiness wrote to Mrs. Venkateswaran is carried on the cover of the book, and now it has also been embellished by his releasing of the book. May I now request Mrs. Venkateswaran to propose a vote of thanks.
Namaste to all of you in the gracious presence of Your Holiness. Once again, namaskar. And I cannot express how happy I cannot express how happy we are that your gracious presence has been on this occasion. And thank you ever so much for releasing this book. And I'm sure wherever Venkat is, it will be to him a great pleasure and a memorable incident. Venkat used to recount quite often about the first meeting that he had with Your Holiness. And after greeting each other, Your Holiness looked at him and said, "I have met you before." And Venkat was taken aback, and he said, "Your Holiness, with your insight, you may be able to remember perhaps even the past birth incidents. But I'm just a mortal, but I don't remember it." And in any case, it's a wonderful feeling we have. And from that day onwards, a warm friendship between both of you was born, and Venkat cherished it immensely. And every time Your Holiness was visiting Bangalore, we would come and get your blessings, and we still cherish and treasure your scroll.
Physical condition quite sort of bad, but he is very much want to meet. And see,
difficult physical. See, at that time, my physical much better. Now my own physical. So you see, our friendship
Yes,
deep inside.
deep inside. So he cherished it, and so this is something which my daughter also has inherited and has come all the way to be here in his presence. I have to thank Ambassador T.P. Srinivasan, who initiated this project and brought it to this level, and Mr. K.P.R. Nair, who is also an old friend of ours, who has published this book, beautifully published it, and Ambassador Satnam Singh for all the help that he gave in making things happen in the proper way. And I appreciate the presence of all of you and all the people who contributed to this book to make it a kind of a living memoir, which is very pleasant to read for all of us. And thank you once again. And this is a beautiful venue and a beautiful occasion to be here. And namaskar. Thank you ever so much.
A big thanks to the ambassador and Mrs. Venkateshwaran. Thank you, Your Holiness, for such valuable words on the book and also for releasing the book. I would also like to thank the ambassador and Mrs. Venkateshwaran for the vote of thanks. I would now humbly request all of you to take your place in the auditorium so that we can move on with the next book release. Next, we have another book release in the auspicious presence of His Holiness. It is with great pleasure that I would like to inform you that this book, entitled Changes in the Roof of the World, Reflections on Tibet, is an edited volume which has been brought out by the PhD scholars, mostly of Tibetan and Ladakhi ethnicity, currently studying in JNU. For this event, I would like to request the contributors and the editor of the book to please come up on stage. I would also like to request Ambassador Lalit Mansingh and Rajan Arya from Pentagon Press to come up on stage. We will begin the book release by the editor presenting the book to His Holiness and would then request the ambassador to come up to the podium and say a few words about the book. Now request Ambassador Lalit Mansingh to come up to the podium and say a few words on the book.
Your Holiness, Mr. Rajan Arya, the publisher, Mrs. Venkateshwaran, Kalpana, all our colleagues from the Foreign Service, distinguished ladies and gentlemen. It's a happy coincidence that His Holiness has released 2 books today, one on Tibet and the other on Ambassador Venkateshwaran. There are 2 qualities that Ambassador Venkateshwaran shared with His Holiness. One, a very direct approach to everything. And second, a great sense of humor. As Foreign Secretary and as Ambassador to China, Ambassador Venkateshwaran dealt with the most sensitive issues relating to Sino-Indian relations. I have no doubt that he dealt with the Chinese with the same directness with which he dealt with every other foreign policy issue. And I am also sure that when he spoke to the Chinese and met their claims on our territory, he replied to them as effectively as he always does, very directly and very firmly. I do not know if the book has references to this, but I recall that one of the first occasions when Sino-Indian relations faced a crisis, there was a border confrontation at Somdurungchu, if people remember, in the mid-80s. And China was given an unmistakable message that it must vacate its illegal occupation of one of our outposts or else face the consequences. And the Chinese decided to withdraw. And this happened on Ambassador Venkateshwaran's charge as Foreign Secretary. Venkat, as we fondly called him, was much more senior to most of us, but somehow we felt that he was part of our generation. He was, as His Holiness remarked, intellectually very sharp and devastatingly direct. I know there are many instances of his wit and humor in the book, but I must recall that I was at the receiving end of his directness on one occasion. I, as always, was a little cheeky with him, and he was Foreign Secretary. I said, "Sir, you are so bright. You must be from Kumbakonam." And he looked at me sternly and said, "Young man, I'll have you know that I was born in your home state." And that put me in my place. And with that, he dashed my claims to be the first Foreign Secretary from Odisha, because he happened to be born there. Now, on the book, it is appropriate that this book on Tibet is released at the hands of His Holiness the Dalai Lama. For close to 60 years, he has been the face, the voice, the symbol of Tibet. The world has been made aware of the injustice, the atrocities, and the indignity suffered by the Tibetans and the way their human and religious rights have been denied by the Chinese authorities. This is not an occasion for us to discuss political issues relating to Tibet. I do not wish to embarrass His Holiness by raising such issue, but I will say, as an Indian, I will say, as I have been saying, and I have said in the book that is going to be released, that India could have done better in supporting the cause of the Tibetans. But that is all in the past. However, it's my conviction that it is not too late to raise the Tibet issue as a core issue between India and China. The importance of this book is that it is written by young scholars of Tibetan origin. Here in this book, I think for the first time, we have the genuine voice of the next generation of Tibetans. So if the Chinese think that the Tibet issue will disappear after His Holiness, I think they're in for a big surprise. Because if the Chinese continue with their policy of repression, the flag will be flown by the next generation of young Tibetans who will keep the Tibetan issue alive until it finds a just solution. So with these few words, I welcome His Holiness, and I wish to thank the publishers for their inventiveness in seizing the occasion of His Holiness's presence to release what I think is one of the most important books on Tibet published by young Tibetan scholars. Thank you.
Thank you so much, sir, for your kind words. Also, a big thanks to the contributors, to the editor, Mr. Rajan Arya, Pentagon Press, for this wonderful volume. I would now request all of you to please take your place in the auditorium. That brings us to the final event of this session. For this, I would like to request Professor Renuka Singh from the Center for the Study of Social Systems, School of Social Sciences, JNU, to please come up on stage. She would like to present the book Dalai Lama's Little Book of Buddhism, edited by Professor Singh herself and published by Hampton Roads, San Francisco. Ma'am, I would request you to say a few words before presenting the book to His Holiness the Dalai Lama.
Respected Your Holiness and friends, I just want to mention that this book came out actually in the summer around His Holiness's 80th birthday, but somehow I couldn't make it to LA, even though Professor Robert Thurman, who's written the foreword to the book, was present over there. So, Your Holiness, I wish you a belated happy 80th birthday by presenting this book to you. May I request His Holiness to have stable life till Sansara ends.
I would now like to request His Holiness to say a few words on the book which was written and edited by the students from JNU.
Our future generations, of the Tibetans, future seeds of Tibet, and the future Tibet. For the past 1,000 years, the Tibet, we had a Tibet for the past 1,000 years. It existed in future as well. And our generations, I'm sure that Tibet will exist, the Tibetan culture will exist for 1,000 more years. One of the reasons is because our Tibetan culture, it's deep, it's very meaningful and useful. When I talk normally about Tibetan culture, I'm saying it's non-violence, peaceful, and based on compassion, grounded on the compassion. Tibetan culture in this world, it's necessary, needed in this world. In the Buddhist philosophy, in the past 50-some years, in all over the world, the places where the Buddhists flourished, there are so many places, the centers of the Buddhism established. When I meet them directly, it's very clear. in Tibet, generally the Buddhism, particularly Nalanda philosophy, as we preserve the Nalanda traditions in Tibet, none other countries have done that. As well as the way we preserved is not in our own language we have preserved it. Particularly the Nalanda, okay, the path and the result. Okay, anyway.
As far as the deep Buddhist philosophical studies are concerned, including the one that is called as Nalanda tradition, everything is available in the Tibetan language itself, and numerous scholars have composed excellent books. And it is perhaps only Tibetan language which is able to explain all these deep Buddhist philosophical thoughts. And that's why we had a fruitful discussion with quantum physics yesterday, and we are continuing that dialogue today. And therefore, when you relate the quantum physics with the Madhyamaka viewpoint, probably such kind of conference is taking place for the first time. And in the Tibetan monastic environment, the monks study for 30-40 years by memorizing the root text, and then study the text in the class, and then go to the debating court and debate the point very thoroughly. So this process of study is one of the finest academic process of study, and therefore you can clearly include Buddhism as one of the main religion in the world today. And this religion, which is counted as one of the main religion today, and the whole process of study is based on reasoning and logical analysis, and therefore we have the capacity to sit together in equal state and position with the scientists and to be able to discuss these very subtle viewpoints. So this, I think, is possible only by people who have studied the Buddhist philosophical viewpoint for many years, and it's not so easy for many others to do that. And therefore the Nalanda tradition, which the Tibetans have been studying, be it the view or the philosophical viewpoint, and especially of course there are some unique Buddhist viewpoints which is related to more Buddhist practices, but generally speaking, the Buddhist philosophical viewpoint is very much related to bringing about morality and transformation of the mind. And it is because of this presence of the Buddhist philosophical values that more and more people from all parts of the world are showing interest in that. So there is this great capacity to benefit many others, to bringing world peace, and which is very much relevant in today's world. So the more people have that kind of importance, the more people show that kind of regard, the more we need to preserve it. And who is going to preserve it? It is you, the younger generation of the Tibetans, who have to preserve it. So therefore it is really wonderful that you young people are taking that sense of responsibility. Earlier in the 1960s, around 1959 and 60s, when we appealed the Tibetan situation to the UNO, Nehru suggested that it is of not much help that you bring the Tibetan situation to the UN platform. And in order to get Tibetan independence, it's definite that Americans are not going to fight for you. And Nehru used to tell that to me. And therefore, when I requested Nehru to assist us in bringing the Tibetan situation to the UN, and then he told me that it's of not much benefit. However, of course, we went to UNO, and then I was thinking how to explain it to Nehru.
and I told him that we don't expect a quick solution coming from UNO, but at least to make sure that the Tibetan situation does not completely disappear, we make it known to the UN platform. And then this is what I informed Nehru, and later on we had another meeting on Tibetan education of the younger Tibetan generation, and there we discussed about the need to have a separate Tibetan school, and the purpose of which is to particularly inculcate Tibetan cultural and religious values. And when we requested this to Nehru, and he said, of course, this is very important. And then the education minister, I think Shri Mali, during one of lunch meeting, and Nehru told the education minister that as a minister of education, that you should form a society, and you must become the chairman of that Tibetan Education Society. And then later on, Nehru told me that if you want to make sure the Tibetan cause is not lost, then the best and the most important method is giving proper education to the younger generation. And I regard and respect it. It's a really valid instruction, and now we have passed already 57 years since we came into India as exile, and during those years, one of the main focus of our effort was education of the younger generation by establishing many schools. And what we want the younger generation to come up with from the schools is a young generation which has like a bird having two wings. On the one hand, you have the traditional values, education of the traditional values, and on the other hand, you also have the modern education. So with this aim, we establish the schools, and as a result, today, from the schools in India itself, those who are born in India, there are many who are born in India itself, and then around 79, 80, numerous when a relation got established between the Tibetans in exile and the those in Tibet during the Deng Xiaoping, and when Jaluthandu, my brother, met Deng Xiaoping, and then made a connection, and then thereby we are able to make a connection between the Tibetans in exile and those in Tibet. Of course, it was not much, not without difficulty, but somehow we are able to make that connection. And since then, many young Tibetans who came from Tibet and entered many monastic studies and also joined secular schools. And all of you have worked hard, studied hard, and as a result, now we are able to some extent, see the fruit. And as I said earlier, you are the hope of the future. And the elder generation, including me, our time is to say goodbye. And it is the younger generation who make this continuous struggle and connection. It is not a struggle confined for the benefit of one generation, but it is for many generations. The generations will change, but the Tibetan race and Tibetan community will continue. So it is but natural that the coming generation must make a follow-up of what has been done by the previous generation. So therefore it is important to not only preserve Tibetan culture, but to promote it. And at the same time, in 1954, when I met Mao Zedong, during the first meeting was official meeting, it's a brief meeting, and the second meeting was meeting with him alone, with the interpreter. And I think the meeting lasted for 3 hours, and I had a lot of discussion with him. And during Mao Zedong, he told me that in the 17-point agreement, there is one point which is establishing a military council, and he said that this probably is not needed, and instead it should be replaced by an idea of self-sustaining or autonomy committee. And I said I will discuss with my other staffs. And when I discussed this with other Tibetan officials, they said this is of course very good idea. And then later on I informed Mao Zedong this is a very, very good idea. And at that time, then Inner Mongolia had already established that autonomy committee, and taking that as an example, we established a preparatory committee for that autonomy committee. So this was based on the idea of Mao Zedong himself. So in order to have a proper functioning of the Tibetan culture and religion, the local officials must be those who have some appreciation and who have some idea about Tibetan culture. And contrarily, if the officials become those who simply control with the communist idea, then the end result is what we have seen in the last many years. So therefore, we have a we have reason to struggle against such wrong policies. So whether it's America or the rest of the world, the process of our struggle is 100% supported by the rest of the world. And in the 7th, 8th, 9th century, Tibet was a completely independent country. And we have on the east China, and then also Mongolia on the other side. And these are three nations with equal power. And this is something that I'm speaking on my own without any reason. I think it was recently in Columbia University. Some of the scholars there, they based on a research that they have done. The research was mainly done based on Chinese sources, and the summary that they brought out in the form of a book states clearly that in the 7th, 8th, 9th century there were three powerful nations. China paid one nation which paid more interest in politics. Then the Mongolian was another powerful nation which showed more interest in military, and then the Tibet was another powerful nation which paid more attention to the religious life. So that was the outcome of their results. So that is the past history. But then that is the past history. Then the situation in those days and the situation today of the 21st century is totally a different situation. So therefore, as I said earlier, taking into consideration the realistic viewpoint, we need to follow a path and means that is realistic of the realistic situation. And if you just remain stubborn and follow a way and means which is not realistic, then it is not going to bring about any fruit. And Tibet, we must remember, Tibet is Tibetans are living as a part of the rest of the world. And so therefore, when we follow the path of non-violence, we are not talking about victory to the Tibetans and loss to the other. So we are following this Madhyamaka view, the middle way, which is beneficial to both the parties. Of course, I have left my political power, but of course I will sustain my effort and interest in culture and religion, and the political matters will be completely taken by the Tibetan political leadership. So I have nothing to meddle into that. But because you have so many young people coming up, I felt it is relevant to explain to you our present situation. So that is the things. Please work hard. As you are doing right now, work hard. And I've been in the past few years also, when I was visiting monasteries in South India, I told them that I'm already 80 years now, 80 years old. And when I'm gone, when I'm dead, make sure that when I'm dying, I do not have to worry about you and about the younger generation. Which means if you are able to come up as such energetic young generation which is fully able to take care of the Tibetan culture, Tibetan religion and so forth, then I don't have to worry. But if that is not happening, I will be dying with a great worry. So it is your responsibility to let me die peacefully. So as I have said there, here also I am saying the same thing. It is your responsibility to let me die peacefully. So please become sensible young people with full of responsibility. Thank you very much.
Thank you so much, Your Holiness, for your kind and valuable words. You have always been and you will always be a huge inspiration for all of us. So with that, we come to an end to the book release session. Before moving on to the next session, I would request our esteemed audience to give us a minute's time as our volunteers set the stage for the rest of the conference. I know we are running a little late, but we hope to make up for this time with the other sessions. Thank you so much. Moving on with the conference, we now begin the first academic session of the day. For our first session today, we have two speakers, Professor Sundar Sarukai from the Manipal Center for Philosophy and Humanities, and Venerable Gishi Jangchub Sangye from Gaden Shadze Monastic University. Our chair for this session is Professor Arthur G. Zions, Arthur W. Mellon Professor of Physics Emeritus, Amherst College, United States. I would request both the speakers and the chair for this session to please come up on stage and take their place. For this session and the others, the speakers will be given 30 minutes each for their presentation, while the remaining time will be dedicated to a discussion on the presentations. So, without further ado, I would like to request our first speaker, Professor Sarukai, to begin his presentation on the topic Wave-Particle Duality and Nagarjuna's Mula Madhyamika Karika. So we are ready to begin the first academic session of the day. I would like to request our first speaker, Professor Sarukai, to begin his presentation on the topic Wave-Particle Duality and Nagarjuna's Mula Madhyamika Karika.
Well, it's a great honor to be here, Your Holiness, to be part of this dialogue, to be able to bring some reflections on quantum theory and Madhyamika, a topic which has been of great interest to me. I'm really grateful for not just this opportunity to present before this august audience, but also to continue this collaborative interest with some of my colleagues over here today. I want to begin with a reflection which His Holiness mentioned yesterday in his introduction when he spoke about how Dr. Ramanna inspired him to look at this relationship with quantum physics. I also have a great debt to Dr. Ramanna. When I joined the National Institute of Advanced Studies over 20 years ago in the philosophy of science, it was he who made me look at Buddhist logic very carefully. He wrote a very important piece which was published in Current Science after a lot of debate among Indian scientists. His attempt was to find a relationship between the fundamental particles, the mass, and the relationship between lifetime. And I remember it was very contentious and we had a lot of discussions about it. And it was then that he really, incited my interest in Buddhist thought, which has developed over the years. So this gives me a great opportunity to place my gratitude to Dr. Ramanna and remember him today. It's very difficult after a wonderful, inspiring talk, a political talk, to come back to the question of quantum physics and Madhyamaka. But in what I'm going to say here, I'm just going to focus on one very simple point. It is a point of response to some of the questions which were raised yesterday. So the summary of what I'm going to say is as follows. I'll first tell you a few words about the wave-particle duality. We heard some wonderful talks yesterday which gave us the background to it, from which I want to raise the question, why should it be of interest to Madhyamaka at all? We also heard about that from Professor Bidball and others, why there is this interesting connection to Madhyamaka. But then I want to look at some criticisms of this relationship, particularly from the larger scientific field, on what are the inherent tensions in a comparative analysis between Madhyamaka and quantum thought. And I want to give a response to it and say why, in my view, Mula Madhyamaka Karika, Nagarjuna's seminal text, is one of the greatest philosophical texts which directly speaks to the question, not just of quantum theory, but of foundational questions in philosophy of science. And I will illustrate it with a very quick example from the text. So in other words, what I want to try and focus on in the next few minutes is to make the argument that much more than the content of a text like Mula Madhyamaka Karika, we need to see the logic of the argumentation present in that text. And there's something very important which Nagarjuna does in that text. So I want to use that to reflect a little bit on how it allows us to make sense of this question of wave-particle duality. So very briefly and very quickly about wave-particle duality. What does it constitute? The essential problem is that there seems to be an inherent contradiction in the ways in which we define or describe a quantum particle. So an electron seems to behave like a particle, and it seems to behave like a wave. And if any of you had a doubt on why should that matter to us, whether it functions like a particle sometimes or functions like a wave other times under certain contexts, then the reason why it should bother us is because, at least in the way in which physics describes particles and waves, these seem to be contrary. In other words, particles are supposed to be localized and waves are extended. So if there is, what kind of descriptions then really matters to an electron? There are various other important differences between a particle and a wave, which causes the problem of wave-particle duality. Waves can interfere, like yesterday we saw many of these talks which spoke about this. Waves can interfere, but particles cannot occupy the same space. It's a very important metaphysical definition of a property that two properties cannot occupy the same space. Waves are characterized by energy, particles by mass. People have tried to formulate these different properties in order to discover what exactly is the problem if you say an electron is both a particle and a wave. There are other important issues, for example, the fact that waves are characterized by complex functions, particles by the values of particles not with complex functions. The definitions of waves are not in real space, like particles being in real space, but in other kinds of representation spaces, like Hilbert space and so on. And this question, one might think, is a consequence of some kind of a problem, the relationship between the observer and the observed. But I want to draw on a work from philosophy of physics, for example, which makes this argument that although there are many resolutions, many attempts at resolutions of wave-particle duality, for philosophy of physics, this particular question of duality becomes very central. So, for example, Gibbons points out that the Copenhagen interpretation, which you heard about yesterday, which resolves some part of this problem of wave-particle duality, he calls it, quote, the philosophy of physics in the broadest sense. In other words, the wave-particle duality is not just an accident of particular qualities of these quantum particles, but, to quote him, it is a philosophy of physics, a philosophy which confronts the limitations on the representations that physics may employ, a philosophy of physics as a cognitive activity. In other words, I think if you take this particular view seriously, that the problem about wave-particle duality is not just about a very esoteric behavior of some small quantum particles, but it actually reflects something fundamental about the nature of philosophy of physics. And it is in that respect that I want to compare and do this relationship with what Madhyamaka does. Now, The second part of my talk, as I said, is on why this relation to Madhyamaka. And we already again heard wonderful talks yesterday which make some connection. But just to situate the problem, let me begin with the quote from His Holiness the Dalai Lama's chapter, the third chapter, The Universe in a Single Atom, which to me was a very wonderful summary of the ideas of quantum physics. He points out that, quote, although the reality of the external world is not denied, it is understood to be relative. It is contingent upon our language, social conventions, and shared concepts. So the reason why Madhyamaka seems to be so centrally speaking to the questions of quantum theory, centrally responding to the paradoxes of quantum theory, is because of this the two different points. One, the observer independent reality is untenable, the point which he makes, and the fact that it is related to the dependent origination, which is about the argument of dependent origination, which is about the ultimate reality of all things in the world. To quote him, no phenomenon exists with an independent or intrinsic identity. This is something which we saw earlier yesterday also. In the 2004 book, edited by our chairperson, author, The New Physics and Cosmology, Dialogues with the Dalai Lama, OUP, there is a particular discussion, and again, it's a very useful book for me, and I'm sure for many others. In one part of the discussion, there's a discussion on wave-particle duality. And in a discussion with Anton Zeilinger, His Holiness the Dalai Lama asks, quote, can you explain why a single phenomenon cannot be both a particle and a wave? What are the mutual exclusive properties of particles and waves? And that's a question which seems to be very central to that particular discussion. In response, Zeilinger shows an experiment, but the discussion seems quite inconclusive. And in the end, Zeilinger says, quote, the way we look at this problem today is to say you can have a wave picture or a particle picture depending on what experiment you do. Now, it might seem, therefore, that there seems to be a very close similarity between certain conceptual issues in the wave-particle duality problem in quantum theory and in certain philosophical conceptual framework of the Madhyamaka. So does that allow us to explore this relationship? So in other words, what I'm asking is, what kind of a relationship exists between the Madhyamaka as a philosophical system and the paradoxes of wave-particle duality? What kind of substantial relationships are present? Or are there certain kinds of similarities, which are analogies between certain kinds of utterances and conclusions which you can make from the Madhyamaka and from the wave-particle duality? Now, I'm saying this because I want to point out a criticism from the philosophy of science framework on these kinds of comparative enterprise. And I want to give a response to it and say why these criticisms are wrong. The first criticism, which is a very important problem in the context of science, and the distinction between Madhyamaka and not just quantum theory, but foundations of physics, is the fact that while this kind of a paradox or ambiguity seems to arise in the case of waves and particles, physics as such, and at the foundational level, physics as such, is very essentialist in character. When it talks about properties of objects, for example, you could say the same question about waves and particles will not work with various other properties of objects, like charge. It is not that simple for you to ask the question like we ask, is an electron a wave or a particle, to ask, does the electron have a charge or does it not have a charge? There are we heard about this question about spin yesterday, and whether the measurement of the value of spin is unknown or not. But the essentialists in philosophy of science might also might respond by saying that the idea of spin, that the property of spin is present in an object independent of its kind of a value that it may have, and whether it's even possible for us to make such statements. I think the criticism from the Madhyamaka view is it's not even possible to assert that an object has something called a spin or some properties called charge independent of measurement. But if you look at the foundational basis of physics, the question of essential properties seems to define not just the macro physics, but also microphysics in various levels. So one of the questions, therefore, is why are there only certain types of duality manifested in the quantum field? If it is dependent origination, the idea of dependent origination is across. It is, for Nagarjuna, the dependent origination is not specified to one aspect of the world and not for the other aspects of the world. The dependent origination is the central core of all phenomena in the world. Then if you take that as a foundational principle of Madhyamaka, how do we then engage with this contradiction or this kind of a tension between the way physics understands reality across all its domains and the way in which it is manifested in the wave-particle duality? Now, the way in which one can answer this question, and the way in which to respond to this question, is that to go back and look at what specifically happens in the wave-particle duality. I mentioned that essentialism is very extremely important. Let me also point out another question which has often been raised in this debate between Madhyamaka and wave-particle duality, which is the role of mathematics. And we'll be hearing more in the next session. But the question of mathematics in the sciences is an extremely important one. And the way in which we understand mathematical descriptions of the world are central to the way we understand what a physical description of the world might mean. Given that, and given the fact that modern science seems deeply invested in essentialism of mathematics, particularly in the ideas of Platonism, that mathematical entities have an independent existence, a non-spatio-temporal existence, a view which seems to resonate so deeply and which is at the heart of the possibility of modern science, then we need to ask the question, does this Madhyamaka framework allow us to have a different understanding of the mathematical descriptions of the world? Does the Madhyamaka Karika give me the possibilities of critiquing Platonism of mathematical entities? In other words, I can't say wave-particle duality is dependent on origination or dependent on factors, but allow mathematical entities to have independent existence, an essential independent existence. And therefore, there is something which is very important in the framework of using Madhyamaka Karika to actually bring this question of dependent origination across all these utterances in sciences. There is another very important relationship between Madhyamaka and wave-particle duality. One was on this dependent origination. The other, which I'm just saying for completeness, which I'm sure many of you know, is a very important aspect of it, which is about the nature of logic, which is used in the Madhyamaka. I'm sure most of you know about the Chatushkoti and the role in which this four-cornered tetralemma plays in quantum theory. So there have been people who have, there have been very important works which have connected the Chatushkoti with quantum logic. Let me just give you one example of why this seems such a very good fit as far as logic is concerned. So this question of wave-particle duality can actually be phrased in the following manner. And I think this is a very natural way to ask it. You can say, is electron a particle? And if you say no, then you ask, is electron not a particle? And you will say no. And you will say, is an electron both a particle and not a particle? And you will say no. And you will say, is an electron neither a particle nor not a particle? The classic structure of the Chatushkoti. Wave-particle duality manifests exactly. Because this impossibility of fixing what the state or whatever the mode of existence of an electron is actually captured by a particular form of logic. Ryug, in this wonderful piece on on the analysis of the Chatushkoti, points out that in the Madhyamaka Karika, the Chatushkoti is used in certain sections, including very important sections on causality, nirvana, and so on. There is a very important function which the Chatushkoti does, and which is to exhibit a particular logic of a phenomena which does not seem to fall into particular patterns, as is it a wave or is it a particle, and so on. Now, very interestingly, in contemporary philosophy of science, a very influential article by Hilary Putnam, a very important philosopher of science, when he writes his seminal paper on the logic of quantum mechanics, begins by pointing out certain aspects of the logic of quantum mechanics, which you can see are actually very closely related to the logic of Chatushkoti. And therefore, in contemporary philosophy of science, for those who are interested, people have been looking at both these Buddhist logical, particularly the Chatushkoti system and the Jaina logic, to understand these different aspects of the logic of which constitutes a quantum mechanics. A very important part which Hilary Putnam makes is this, that the peculiarities of quantum mechanics arises through the illegitimate uses of classical logic in the description of individual quantum system. And therefore, the implication is that it is not that probability in quantum mechanics, the point he makes is that probability in quantum mechanics is classical, but it's only the logic of quantum mechanics is non-classical. Putnam is also making this larger argument by wanting to argue that logic is empirical, something which all Indian logical systems would have told them 2000 years back, because the very essential aspect of Indian logic is their empirical nature. So we see therefore that you can have a completely different rereading of the wave-particle duality, not just in terms of the philosophical foundations of the Madhyamaka, but also in terms of the logical structure which is central to the Karika. In having said this, I will now focus on 2 points as a response to the particular kinds of problems which I set out. One is the response on what does this wave-particle duality actually imply. And the implication of wave-particle duality, we saw many ways of looking at it. I'm just going to focus on one very specific issue for the context of time, in the interest of time. And this is about Bohr's complementarity principle. I mean, much has been written about it, and we have already heard many things over here. But I want to look at this notion of complementarity to show why this question of this philosophical interface between Madhyamaka Karika and the philosophical foundations of quantum mechanics are deeply related. The first interesting point to me, and this is a point which Bohr held, and there are many who didn't agree with him, and still many do not agree with him, but I think there is something which he says there which I want to use to make sense of this debate here. So, in 1929, Bohr says this about complementarity. The quantum world, quote, forces us to adopt a new world of description designated as complementary, in the sense that any given application of classical concepts precludes the simultaneous use of other classical concepts. That is, descriptions are complementary. And Bohr uses in that Como lectures, he uses complementarity about 15 times. And he shows how complementarity can also already be used in different particular ways. The idea of complementarity is the particular point which Bohr is pointing out. I think it's very extremely important to a philosophy science understanding, which is what? That there seems to be a kind of a tension between use of what he calls as classical concepts to describe the quantum world. So, and therefore, so we could look at this in different ways. The fact that we have some notion of ideas of classical world, which when used to define the quantum world inherently lead to problems. There are very interesting questions about this, and I think you can debate this for a very long time on whether there are classical concepts at all, whether there are concepts which only hold for the macroscopic world, and that there are something called quantum concepts that are different from classical concepts. For example, for Heisenberg and Einstein, this kind of approach that would not make sense, and I'll tell you why. So, but there is something very important about the idea of Bohr, and this is what Gibbons is saying when he says complementarity principle is the philosophy of physics, which is that what they are asking us to consider is the fact that the description of the world breaks down at a certain point. Now, it is very facile to connect this to the two truths doctrine, but it is also true that the ways in which we understand the ordinary world may not be, the conceptual way in which we cognize and understand the ordinary world may not be enough to understand an ultimate reality or whatever. And the tension between the two truths should also be seen as the limits of the conceptual world that we have in order to talk about phenomena. Now, if you look at it in that manner, then there is something which is very important, which to take from Bohr. So for Bohr, there's a breakdown of classical concepts and a breakdown of classical explanation, which is very important, which is manifested as this problem in quantum physics. Now, I want to use that idea and expand it to this question of complementarity between science and philosophy. The first point is, if you think there is a distinction between the classical and the quantum, that the classical concepts are not enough to describe the quantum, you can rephrase this binary in different ways. I'll just give you a few examples. One is object-centered language and ensemble-centered language. That is, when we talk about phenomena, we often talk about it in terms of description of objects. And as many of you know from philosophy, it's been very difficult to find language to talk about processes. In fact, for science, starting with Newton's, a very famous example of Newton, who uses this process of nominalization, which is to convert verbs and processes into noun language. So you convert, so science creates a large number of noun terms, So you can actually read scientific texts as just a list of noun terms. And that's a linguists study this and point this to this process of nominalization, which means science is far more comfortable converting processes into things. And that language is very different, the object language and the ensemble language or the process-centered language. There is also a very similar problem between the language of the individual and language of the social. Very often when we try to articulate the concept of the social, the simplest way in which we talk about the social is as a collection of individuals. It's extremely difficult for you to have a conceptual world where you talk about the social without reference to the individual. You also have a very similar distinction between the physical and the mathematical. And what I'm sure with the mathematicians and physicists here, many of them might perhaps understand this. I've heard many physicists who tell me, some of them would say, I see this world physically, my intuition is physical. Whereas for somebody else, they say, my intuition is mathematical. They see the world in mathematical concepts, they see the world in physical concepts. I also want to suggest in the same domain that the real distinction is between the scientific and the philosophical. That is, the complementarity which functions at the classical and the quantum, the individual and social, physical and mathematical, is also illustrated in the complementarity between the scientific and the philosophical. In other words, what is the implication of this? That one of the greatest difficulties in this cross-debate and dialogue has been the use of the same concepts across different domains. So philosophers have the same conceptual term, mass, matters, space, time, and motion. So I'm going to use these simple examples, which is also central to the Karika text. Okay? So if you look at the idea of the concept motion, space, time, and causality, for example, causation, both these concepts are available to both scientific use and for philosophical use. And what I want to suggest to you is that these concepts actually manifest complementarity. That is, just as an electron manifests wave behavior and particle behavior, the same concept of mass, space, time manifests and sometimes behaves like a scientific concept, sometimes behaves like a philosophical concepts. And much of the tension when you have this kind of an engagement between concepts is primarily because when the philosophers are using these concepts, they're using it in particular sets of meanings associated with it, and when the scientists are using it, they are sometimes using very different sets of meanings. So the fundamental tension between essentialism and non-essentialism is actually reflected in the way we use these concepts. So where then does, why should the Karika really matter to this kind of a debate? The best example for me, and which is something which I really enjoy reading, one of the best texts which I have seen as a philosophical text, if you look at the first two sections of the chapters of this text, the first is on causation and second is on motion. And as I said when I began, that the real point about reading the Karika is not to see what it says, and that is over very quickly, dependent on origination, but how it makes an argument. If you look at the motion chapter, it's a really, to me, it's one of the most pleasurable chapters to read, because the way it makes an argument for denying this kind of a dependency or kind of an independent intrinsic value is of great interest when you understand, when you want to analyze the category of motion. None of what the chapter says about motion will be easily acceptable by physicists, because that does not fit the scientific idea of motion. The possibility of motion as a scientific concept depends on various other kinds, including the possibility of absolute space, absolute time, possibility of markings of space and time, movements, and so on. Whereas Nagarjuna's reflection on motion is completely different. Now, what is it? So, since I don't have time, but you can really look at this very interesting comparison which Sideritz has done on the idea of motion, the Zeno's paradox in Nagarjuna and in Zeno's. You know, the famous examples of Zeno's paradox, which argues against a logical coherency of the idea of motion, and how Nagarjuna sets it up. And for both of them, Sidritz's argument is that they are both talking about the divisibility and multiplicity of space and time. So it's a very fascinating way of trying to make sense of what Zeno and Nagarjuna are doing when they deny the idea of motion, a logical coherence in the idea of motion. Something which runs counter to the very possibility of motion in science. So how do we then make sense of this particular thing? So to me, the way out is to actually, and I'll just conclude here, is that the one of the best ways for me to do it, and it's a great exercise which I want to engage in, which is to go back to looking at the complementarity by looking at the Bohr-Einstein debate. When people ask, how do you actually use a text like Karika into this, in the philosophy of science here, I say enter the Bohr-Einstein debate, and the way I would really like to see it is to actually have a Bohr-Einstein-Nagarjuna debate. Nagarjuna is the intermediary between Bohr and Einstein. Bohr and Einstein do not understand each other. There is no comparability between what they are saying. And what a text like Karika does is it allows them a way to talk to each other. And one of the biggest problems with this, I'll just give you one example and I'll stop here, that when Bohr and Einstein meet, Einstein's greatest problem about complementarity and Bohr's picture was actually about causality. In letters in 1920, he writes to Bohr and he says, quote, "The question of causality worries me a lot." And he goes on to say, "I should be very, very loath to abandon complete causality." And then in 1924, he writes to Born, and he says, "Bohr's opinion of radiation interests me very much, but I cannot give up, he doesn't want to give up causality." And he says in a very memorable line, "If so," that is, he doesn't want to see electrons making their decisions to jump. And he says, "If so, I'd rather be a cobbler or even an employee in a gambling house than a physicist." It's true my attempts to give up the quanta palpable shape have failed again and again, but I'm not going to give up hope for a long time yet. That is, Einstein's problem is about particular notions of causation and causality, which seems to be contrary to what Bohr is saying. But neither of them are drawing on the rich philosophical conceptual term of causality. And it's very interesting what Einstein does in EPR, in defining reality, which is something which most philosophers would not even understand. But they define reality and go ahead with, say, using that as a framework for doing it. So my point about putting Nagarjuna in between Bohr and Einstein, or to call it the Bohr-Einstein-Nagarjuna debate, is to actually allow the philosophical vocabulary of the Karika to actually mediate between Bohr and Einstein, because what Nagarjuna is doing is actually giving you philosophical clarity on these ideas of causality, motion, and so on. And this is, of course, hope, which hopefully somebody will do it, or if I have time, I should look at it. But it is, to me, the reason why I think it's very important for me to look at it in this manner is because I think there is something in the Madhyamaka Karika which is not just about, and this is my final conclusion, which is not just about saying that quantum world matches the dependent origination thesis of Karika, or about its response to the intrinsic properties. To me, there is a hope. I think yesterday Professor Rajaram mentioned about new conceptual terms happening in science. And to me, that the real hope of an engagement with texts like Karika is that our conceptual, the scientific conceptual term for matter, motion, particularly about motion, space, and time, have to be refigured. And the real, I may be completely wrong, but I do think that new physics will happen at the interface where new theories of space and time in the quantum domain are going to be refigured. And we have these philosophical work on space and time and motion. Just at those three concepts, you don't have to go to any other concept, which actually allows you a very meaningful way to engage the Karika with these particular issues of quantum physics, and thereby lead us to consider the possibility that the Madhyamaka Karika, Mula Madhyamaka Karika, can actually help us create new scientific concepts which are of use within science. Thank you so much.
Thank you so much, sir, for that wonderful presentation. Moving on to the next speaker, we have Venerable Gishi Jangchub Sangye. He will be speaking on the topic, Dependent Origination, the Absence of Intrinsic Existence and Tenability of Conventional Phenomena, according to Prasangika Madhyamika System.
Tenju domla. Dame shagi to sabde mai ni malu kisha. Tuita tenju tam ye lutu mi tenju keve o
Verse that pays homage to
samu
Buddha,
tenju ki dekonani. Tomba ta tenju sini.
the profound dependent origination and profound emptiness was first taught by Buddha, and then after his passing away, it was when the view of emptiness, people who would understand view of emptiness got a little bit degenerated. Then Nagarjuna came as a pioneer to rekindle this view of emptiness. And there has been many ups and downs with the understanding of emptiness. And today, in the whole world, many of learned scholars are showing much interest in dependent origination emptiness. And it is a much discussed subject. And especially many of the modern scientists, science scholars, among them, there is also a lot of interest, and there has been a lot of discussion. So all this is happening because of His Holiness Dalai Lama. So these are the great people to whom I want to pay my homage and show my reverence. And I also would like to extend my respect to all the participants, the science scholars, the Buddhist scholars on Buddhist, the monks who are scholars on Buddhist philosophical views, and the teachers and faculty members and students of this university, and likewise all those who have specially come for this conference. I would like to extend my respect and greetings to all of you. And the topic of my talk is the acceptance of functionality in the absence of intrinsic existence according to view of the Prasangika school of thought. And I have actually distributed my composition. The composition has more than 10 pages. And I know that there is no time to read or explain all of them. I would try to summarize it. And in the composition that I have distributed, the topic of my discussion is the Prasangika Madhyamaka school's thought, which does not accept any intrinsic existence. So this being the case, when Buddha turned the second wheel of the doctrine, the Wisdom Perfection Sutra, and then Nagarjuna was prophesied as the one who will interpret this thought. And likewise we had Aryadeva, Buddha Palita, Shantideva, Chandrakirti. So these are the masters, great scholars of the Prasangika Madhyamaka. So they have also composed numerous commentaries, and likewise there are numerous commentaries by Tibetan scholars, and also there are a number of commentaries written by His Holiness Dalai Lama. So based on this text, as I am going to make my presentation, and in general, in order to ensure that what I've written becomes more comprehensible, I've also cited the quotations, the sources as a footnote, as an annotation, and those of you who are interested can read those. Now, according to Prasangika Madhyamaka viewpoint, the main philosophical viewpoint is that things do not have inherent existence, but still they can function on an ordinary level. So this is the main point. Different philosophical systems have they talk about two extremes, and everybody profess that they are all Madhyamaka, they're in the middle way. But according to Madhyamaka, the extreme of permanence means independent existence, or in terms of the subjective mind, it's the mind which sees things having independent existence. In terms of nihilism, it is to say that if things do not exist independently, they should not exist at all. So therefore, it is important to make this presentation that things do not exist independently does not mean things do not exist at all. They exist very much, and therefore they function. So therefore, the object of negation is inherent existence. Inherent existence means something that has existence without depending upon anything else or anybody else. So there is kind of objective absolute existence. The reason that things do not have independent existence is there are hundreds of reasons, and hundreds of scriptural citations have been done. Out of these many reasons, the main reason, which is like the king of all the reasons, is the reasons of dependent origination. This is called the king of all the reasonings, which means that if you bring down the essential points, then this is related to the concept of dependent origination. Dependent origination means that the way things come into existence are relative. They are dependent upon other factors. And among the concept of dependent origination, there are different ideas. One is the cause-effect relationship, the dependence in terms of cause-effect relationship. Then there is a second notion of dependent origination in the terms of the whole and the part depending upon each other. And then thirdly, dependent origination in the sense of things being designated by the mind. But according to some texts, they classify it into two, the cause-effect relationship and the dependent origination in terms of designation. And in the case of designation, they talk about two, the whole and part dependence, and the dependence in terms of conventions and names. The cause-effect relationship dependence is something that's accepted by all the Buddhist philosophical systems. So in terms of this understanding, whether it's the external things like mountains, forests, or it is internal experiences like your body, your speech, your mind, and so forth, all of these phenomena, they do not come into being without depending on causes and conditions. They all come by depending on causes and conditions. And the causes conditions are not those that are permanent, or there is an external mover and shaker which creates everything. So that is the idea, that's the understanding. So in the case of the dependent origination in terms of cause-effect relationship, it's important to have an understanding of the grosser understanding of cause-effect relationship and the subtler understanding of cause-effect relationship. The cause-effect relation related to the external situations and the internal situations. But here I'm not going into detail. I'm merely talking about the topic called the mere conditionality. The mere conditionality is a term that comes across in the auto-commentary of Madhyamaka Avtara by Chandrakirti. And but still, this word, mere conditionality, is not a unique terminology used by Prasangika Madhyamaka. It comes also in the certain commentaries, like the commentary by Swandvipa, The Light of Reasoning, and similarly Lhawang Lo's commentary on epistemology. In many of this, and Kamala Shila's major commentary on epistemology, they also use this word, mere conditionality. So from the parlance of the Buddhist as a whole, Buddhist philosophy as a whole, the mere conditionality means that things are not created by an external creator, but they merely are product of their respective causes and conditions. So that is the general notion. Then second idea of dependent origination, the dependence on the part and the whole. According to the philosophical systems, tenet systems, according to Prasangika Madhyamaka and Swatantrika Madhyamaka, this is a philosophical viewpoint accepted by these two schools of Madhyamaka. And in the case of physical form, it has parts in terms of directional parts. In the case of mind, which is non-physical, the part is understood in terms of it is momentariness, and in the case of unconditioned phenomena, like a permanent phenomena, it is termed as having parts in terms of how it is designated by the mind, and in terms of how it is designated on other conditioned phenomena. So here, when we talk about primarily the body and the mind having parts, so in the quantum physics, when you talk about the parts, it is talking about the physical entity and not talking about the mental continuity or momentariness of the mind. It looks like that. According to what I have heard, it looks like that. It is merely talking about the physical entity and not talking about the mental continuity. It looks like that, according to my understanding. Now, in the case of the third understanding of interdependent relation, which means things are merely designated, that whatever is there is a product of mental designation, and if you're not satisfied with this mental designation, and instead if you try to analyze the object of designation and try to locate it and find it, it is not findable. So out of these three notions of dependent origination, the last one is the most subtle one, the subtlest one, which is accepted by the Prasangika Madhyamaka school. So in the case of the idea that things are merely designated, it means that the basis of designation, if you try to locate it and pinpoint it, you will not be able to find it. That is one meaning. And second, that it is designated by the name. And since you are not able to find the basis of designation, that clearly shows it is designated by the mind. But then this leads to the next question that, okay, if that is the case, then can we use names in terms at the conventional level? And can things function at the conventional level? Yes, very much so. So then what do we mean by the basis of designation, and what is the process of searching the basis of designation? Basis of designation means the basis or the object where we apply the names. For example, in the case of the person, it is something that designated on the psychophysical aggregate. So the basis of designation is the person itself. Although that basis of designation is the person, but if you search, searching it does not mean whether it is existence or not, but it means what is the process of it is coming into existence. So when you search in this way, as you have designated, and try to find it as you have been designated, then you will not find that person. So this, when you do not, through this process of search, when you do not define, does not find the person, does this mean that there is no person? No, it is not the case. So if things have inherent existence, then when you search, it should be findable. But when you search, you don't find it, so that shows things do not have inherent existence. But on the ordinary level, when you search things, if you don't find them, this does not mean that they do not exist. So this all comes to the conclusion that things are merely designated by name and by designation. If I give you an example, for example, when we call a pot something that has a hollow inside, and for example this table in front, okay, without any disagreement, we all say that there's a table in front of you. But if you try to pinpoint that table, where is the table? Is it the legs, 4 legs, or the top of the table, and so forth? Then you will not be find it. But in this way, when you're not able to find the table, this shows the lack of inherent existence of the table and not the non-existence of the table, because at the conventional level, the table is very much there. Because ordinarily, on the conventional level, we posit things without do analysis. But when you analyze the object of designation, you will not find it. Now, what do we mean by posited by the thought, or things merely designated by the thought? Now, according to various Buddhist schools of thought, when we use the subject and the object, when we use the mental designation and so forth, and then a question is raised, which one is important? Object is important, or the subjective mind is important, or are they of equal importance? When such a comparative study is made among the Buddhist philosophical schools of thought, then according to the Vaibhashika school, the lower schools of the thought, they primarily pay more attention to the object. Then higher schools of Buddhist thought pay more attention to the subjective mind. And for example, in the mind-only school of thought, things are merely designated. I have not seen a particular line which says things are merely designated. And they say things exist from their own side. But it looks like they are merely designated by the thought. According to, again with the concept of thought, there are various interpretations. But according to the Southern Tika school, with the phenomena, there are two. One is permanent and another is impermanent. And so according to them, the impermanent phenomena are not mentally designated by the thought. They have inherent existence. And the permanent phenomena are mentally designated and do not have inherent existence. So this is their understanding. Then in the mind-only school of thought, the whole phenomena is categorized into 3 types. And the mentally designated, there is a category called mentally designated, which are of course mentally designated, and the other 2 are not mentally designated. And then in the Svatantrika Madhyamaka school, they accept both the object coming into existence from their own side and also it being designated by the mind. According to some texts, they say that they are designated by the mind, but they are not designated through the power of the mind. So they make such distinction. So anyway, when we talk about valid mind, they talk about both the conceptual and non-conceptual mind. So the Svatantrika Madhyamikas pay equal attention to both the subject and the object. And in the Prasangika Madhyamaka school, out of the 2, the object and the subjective mind, the predominance is given to the subjective mind, because they say everything is designated by the mind, and apart from that, there is no object having inherent existence. So therefore, they say everything is merely designated by the thought. There are many examples, but if I give you one example, for example, take the example of a rope, a coil of rope, which is lying somewhere, and when that coil of rope has a kind of different colored rope, and so if you see that coil of rope at a time when there is darkness and when you are not able to see it properly at a distance, and then the way the coil is lying there, and the color and etc. By seeing that from a distance, when things are not, when the light is not enough, then you will see that coil of rope as a snake, and you get scared. But if you approach closer and try to see whether there's really a snake there or not, then you will find that there is no snake, and your fear will go out. So in this way, when you search and analyze, you will not find anything that is a part of the snake in that coil of rope. So similarly, with reference to our psychophysical aggregate, among the psychophysical aggregate, if you try to locate the so-called I and the person, you will again not be able to find it. You will not be able to find that person among any of the psychophysical aggregates individually or collectively. But this does not mean to say that the I is not there. The I is there by depending on the psychophysical aggregate. So designated by the mind and designated by the thought is more or less same. One example that I would like to give how things are mentally designated is look at these three rooms with similar color, similar shape, and having constructed such houses. You have two situations. One, in the beginning, when no names are being given, how you are going to use those rooms, and then later on you give a name that the first room is for. When the name is not given, then you cannot say the first room is meditation room, and the second room is sleeping room, and third room is for restaurant. But having constructed the room, and then the owner of the room gives designation that the first room is the meditation room, the second is the sleeping room, and the third is the kitchen. And just by the designation, the first room becomes the room of meditation, the second for sleeping, and third for kitchen. But you can see that just by giving their name, there did not occur any changes in the room itself, but just by designation, you will understand them differently. So there is a difference. So you can find out that things are merely designated. Now earlier you have called, now if you have not given this name, meditation hall to the first room, and if you instead call it kitchen, and the second is meditation room, and third is sleeping room. Earlier it was meditation room, now it is different. So whatever phenomena it is, they are merely designated. And whatever products produced from a factory, depending upon what names you give, they will function accordingly. For example, after the birth of the child, also you give a name, and then having got this name, next time when you call by that name, that person will function. So it is just the name that is given. Things are posited and things come into being. So this next crucial point is that things are merely designated, but still on the conventional level, things should function. If things are, the difficulty here is that if things are merely designated, and does this mean to say that the mind can create anything? And then how would things function at the conventional level? So this is the really difficult point in the Prasangika Madhyamaka school of thought. So now with regard to this point that things are merely designated, but still on the conventional level things can function, Buddha Palita, the great scholar Buddha Palita, cites a quotation from the Buddha. The sutra is called Ratana Kudika. There is a beautiful explanation there. He gives some examples there. For example, in a temple, on the wall painting, if you see many of these images of Devas, and two people go inside that to get a darshan of that temple and the images there. And out of these two, the first person says that depending upon the hand gesture, the one who is holding a trident is Vishnu. One who is holding the wheel is Shiva. So this is the comment made by the first person. Then the second person, no, you are wrong. The one who is holding the trident is Shiva, and one is holding the wheel is Vishnu. So when they are having this disagreement, third person comes and he says that both of you are wrong. These are just paintings. It is neither Shiva nor Vishnu. So do you think this will solve their debate? But of course, this will not solve the disagreement, because the first two persons were, of course, aware that these are wall paintings. And they are not saying that they are actual Shiva or Vishnu. So the method is, instead, if he says that the first person is Shiva and the other one is Shiva, if you say in this way, then you are able to solve the disagreement. So it is on this level that things function. As is known to the parlance of the worldly people, you can solve the disagreement. So according to the worldly parlance, they give a designation and then things function. And beyond that designation, if you try to go further and analyze deeper, you will not be able to find them. So whatever we are positing in the ordinary world, we do so according to worldly conventions and according to their things function. So this is a wonderful example found in the commentary Buddha Palita. And then also Shantideva, in the meeting of the Father and the Son Sutra, he cites an example of how things are illusionary in his text called Compendium of Precepts. And here in this case, an example is given how a chariot, due to its function, can accept. Then in the precious garland, also there is a quotation where Nagarjuna says that things are relative, like the long and the short are relative terms. Comparing to something, it may be long, but comparing to something else, it may be short. So if somebody asks you a question whether this tree is tall, they will say, yes, it is tall. Others will say, no, this is short. Some will not answer at all. So if you find out who has correctly answered, you cannot say that one who said the tree is long is correct or short is correct. So so it's only in relative terms that you can talk about something as long and short. So comparing to something that is long, something can be called short, and comparing to something short, something can be told long, and without relating to something else, you can out of the blue say that this is long or this is short. This is the viewpoint found in the precious garland. So whether it's long or short, part and whole, cause and effect, subject and object, they are all relative and dependent upon each other. And therefore there is no intrinsic or inherent existence. So this is the word found in the precious garland by Nagarjuna. So the question raises here is, as I've explained earlier, in the case of the object and the subjective mind, in the Prasangika Madhyamaka school, name plays a dominant role, the subjective mind plays a dominant role. So the question arises, does this mean to say that your mind can designate anything? And if that is the case, this is a wonderful news. Then you can call a piece of stone as gold and you become rich overnight. Then in that case, everybody can become rich. If this is the case, then this contradicts the worldly conventions. So the way to solve that problem is that any designation that we give should fulfill three features. Of course, there is again disagreement among scholars, but according to what is found in the great stages of the path, the Lamrim Chemo by Tsongkhapa, their things are of course designated, but this does not mean that you can designate anything and create anything. That means it should first of all be known to the worldly convention, and second, it should not be contradicted by other worldly conventions, and the third, it should not be contradicted by a mind that sees the ultimate reality. So what is known to the conventional mind means a mind which is not analyzing the ultimate truth. Now, even if it is known to that conventional mind, but if it is contradicted by another conventional mind, then you cannot accept this. For example, if you ask a question, are you there yesterday? You say, yes, I was there and I'm here also, but strictly speaking, it is not there. It is already gone, undergone change. And thirdly, like intrinsic existence, for example, although its intrinsic existence is probably not contradicted by the worldly convention, but it is contradicted by a mind that sees and analyzes the ultimate truth. So if I summarize the points, the object of negation does not have inherent or independent existence. Inherent independent existence but the reality is things are being designated. For example, in the cause-effect relationship, it is dependent on causes and factors. In the case of permanent phenomena, it is dependent on the designating mind. So therefore, they do not have absolute inherent intrinsic existence. And therefore, they are dependent upon, since they are dependent upon others, so therefore, they do not have independent existence. So therefore, it is on the level of appearances that we can confirm dependent origination. And it is because of the notion of emptiness, of a lack of inherent existence, that things function on the level of appearance. There is a detailed explanation on this by His Holiness Dalai Lama, and I'm bringing about here a few points to summarize my talk. Generally, in the major world issues of politics, economics, environment, health, and other topics concerning the well-being of humanity, if we could look at them by applying the concept of dependent origination, our way of thinking could naturally become broad and versatile. The more broad and flexible one's mind is, the greater difference it will make in tackling any difficulties in one's thinking that arises. Nowadays, many people are concerned merely with things that they can see and touch. They do not understand the dependent origination of cause and effect and the dependent origination of dependent imputation. People face many problems due to not knowing these realities. Thus, it is crucial to be well informed of all the facts. And in this respect, the view of dependent origination is very helpful. Therefore, I feel that although the theory of dependent origination is taught in the classical treatises of Buddhism, it should be applied to all matters concerning this world, this is something that could happen, and it would surely bring much benefit, much implemented. And in the ancient Tibetan Buddhist tradition also, the Buddhists have debated with the existing non-Buddhist schools, the philosophical viewpoints of the non-Buddhist schools of thought at that time. And in today's time also, it is wonderful that we are having such dialogue and debate between Buddhist philosophical view and scientific view, and it will be wonderful if we are able to continue such a dialogue and discussion in the future. And this is a wonderful vision of His Holiness Dalai Lama, and it is my fortune that I got this wonderful fortune that I make a very small, tiny bit participation in this, and with great faith and happiness, I bow down to His Holiness.
So our time is almost up, but let's have a couple of short questions, and please direct them to one of the two speakers.
Tatuzu paje zoxuns ina tiwa chigni chitang na tigmendos tiwa tungtungchi.
Oh, no, over here to the right first. Yes. Please keep your questions short.
Tiwa tungtung na ro nans. Ndihi jaya tiwa soro tende memba chi tiwa tungtung na ro nans. My question is to Sarukai, Professor Sarukai, about the wave and light.
The Gishila is asking a question on particle mind, particle wave duality. You need more clarifications on the wave particle duality. Now he wants also a clarifications on the longitudinal wave of the sound, because he said that he learned about the transverse wave, which is sort of there's a crest and trough, whereas a longitudinal has only the rarefaction and the compressions, and he's a bit he wants a clarifications, because he learned that the sound has longitudinal wave.
You want to keep the question short, please.
Thank you.
You know, I think the question concerns wave-particle duality, longitudinal and transverse waves. These are rather technical sound waves, yeah. Can you say something very briefly to that?
Very briefly,
Okay. You have to wave it, it's better. It doesn't work. No. Yeah, the other way. Thank you.
Are you on?
Okay, sorry, I didn't get your full question because I think the translation was not there. I just very briefly I understood, and I think Mr. Anton will probably speak more about those experimental
Yes.
parts. The difference between classically the difference between this light wave and the sound waves are well known. One is propagation with no medium, one with propagation with medium, and therefore the way you describe the disturbances and propagation of disturbances is qualitatively very different across the two, right? And the examples, for example, of the very interesting examples on duality are based on the polarization and cutting off particular polarizations and so on, which I suppose he's going to talk. So in the case of sound waves, it's very different. So,
Right.
is there? I
think
didn't
that's
understand what the
probably good
question
enough.
was, yeah.
I will be
Yeah.
returning to that in my talk at the end of the afternoon.
Yeah.
Other questions?
The question he posed to me regarding the process of searching the base of designation according to this Savatantrika Madhyamaka school and Prasangika Madhyamaka school. According to the Savatantrika Madhyamaka school, they say that basis of designation, if you search them, you will find it. But Prasangika Madhyamaka say that the basis of designation, if you search, you will not find it. So according to this Savatantrika Madhyamaka school, that if you search the person on the 5 psychophysical aggregates, you will find it, because you will find the consciousness as the person. And the Prasangika Madhyamaka say you will not find it. So that is the difference between the Savatantrika Madhyamaka and Prasangika Madhyamaka. The process of searching is same, and not finding or finding the basis of designation, there is a difference. It's not only Savatantrika Madhyamaka, but also the other lower schools of thought. They do not. They accept that if you search the basis of designation, you will find it. But the question is not finding the basis of designation, object of designation. Is it emptiness? That itself is not emptiness.
Bob?
Yes, for Professor Dr. Beautiful Sundaram. You mentioned that the issue of the juxtaposition of Madhyamaka and science, of wave-particle duality, a lot of it turned for acceptability on the ability for mathematics to function in connection to the Madhyamaka. You said that. So in the light of the Geshe-la's beautiful proof from the Prasangika point of view of how all conventional systems function very well, even though they cannot be discovered under ultimacy-seeking analytical condition, is the fact that shunya, the word shunya, is the word for zero in Indian mathematics, which in the decimal system was discovered by Indian mathematicians. So is it the only problem for science with their love of mathematics is that they want mathematics to contribute to some intrinsic essentiality or reality in things, and if mathematics is acknowledged to be a conventional language, there may be no such problem, and even it will function better if they can deal with wave-particle duality. And in that sense, may I ask one question? Is the wave actually, by definition, is something infinite because it has no fixed boundary, whereas particle seems to be a bounded, limited thing. So that's why it's so confusing, the wave-particle irreconcilable duality. But the fact that conventionally one can function under such a duality is perhaps a lesson taught by Nagarjuna and especially, and then Chandrakirti, Prasangika Madhyamaka. Does that help?
Yeah, just to add on to this point, The first point about mathematics is, I think, very crucial because there's a lot invested in the development of quantum theory with mathematical entities, right? Now, so on the one hand, you have the practice of mathematics, the using of mathematics to find structures and so on. On the other, if you look at the foundational issues of mathematics, then the fundamental question which still remains so central to philosophy of mathematics is, do mathematical objects exist on their own? Is there a notion of independent essential existence of mathematical objects? Which is something which the mainstream philosophy of science and scientific practice are not able to let go of. Now, I'm just bringing that problem in order to ask the question whether the way in which you understand quantum theory through the Karikas can help us answer this. So this has been the whole question of Platonism in mathematics and the critique of Platonism in mathematics. One way of understanding the dependent origination of mathematical entities is to say that they cannot occur by themselves in a Platonic world, out of touch with the world, the spatio-temporal world, and that they are dependent upon not just the structure of the world, physical world, but also on the cognitive structures of the human mind. Once you place that argument, then you have a very strong critique of independent essential Platonism, which underpins the foundations of science today. And I think Karika does it. Huh?
They wanted to underpin the foundation of mathematics, but maybe it doesn't really.
It doesn't really is a counter argument by some of us, including myself, who is an anti-Platonist. And I think the Karika gives me the vocabulary to do that.
So then maybe your solution is that to cure them of the intrinsic reality habit under mathematics, you have to don't give them a PhD until they read the Mula Madhyamaka Karika.
Yes, that's generally a good idea. Yeah.
Yes, Professor Bitbol, Michelle.
If I would like to ask two short questions to the two speakers.
Okay.
If not, I can ask only one. So my first question is to Professor Sarukai. I very much appreciated your talk and agree with many things you said, of course. But I had a little concern about the issue of whether in physics you still have a remnant of essentialism. You said that in physics there are still properties that are considered essential to the object, such as mass, charge, and absolute value of spin. But I think this is only in past physics. In very recent physics, we have seen that even these so-called absolute quantities are in fact relational. For instance, mass is now considered not as an intrinsic property of the object, but as a property of the relation between the object and, say, the Higgs field. The same for charge and modulus of spin, because, for instance, charge is considered as what we call an observable, first of all, which is relational, but a super-selective observable, which means that some consequences of the fact that it is relative disappear, namely the wave-like consequences of its being relational disappear. And this is due, according to recent theories, to a process of self-decoherence. So I think the most general framework in which one considers qualities and properties now in quantum physics is entirely 100% relational. So would you agree with that?
Yeah. Can I respond right now? Or?
Yeah,
Okay.
I think, but this may be the only question we have time for, since we need to go to the next person. So,
well, very briefly, the point about the essential the argument about essentialism within these scientific properties comes from a whole tradition within philosophy of science. So I'm looking at the philosophy of science trying to make sense of the narratives of science, like Brian Ellis's work and so on. Now, a part of it is related to a very deep and deep underlying problem structure of science, which is the symmetry laws, right? So you need to make sense of the ontological structure of symmetry laws. What kind of an ontological commitment are you going to do? So I think the essentialist argument that it is impossible to make sense of the way we talk about the ontology of physics makes a commitment to essential properties. So what you are suggesting, and I think I am very sympathetic to that, which is that the way you break up the description of the world, not in terms of objects, properties, and relations, but in terms of other kinds of sortals, which is what Garfield, when he talks about causality from the Karika, points out that what you have is ontological plenty. You can have anything as long as it's dependent causation. That's about it. So there is no sortals into properties and objects and relations. Then we are okay. The main question I have with this relational view, and I find it as a general problem within the larger, particularly the Western philosophical tradition, is we don't seem to have a good grounding of the ontology of relations. As you know, that's been a central problem throughout Western philosophical history. What kind of an ontology would I want to commit to relational entities, right? So whether, I'm not
That's a great
taking the side of
question.
the essentialism, but that's, I still think it's a very open question in philosophy.
Maybe we could leave that question open because it is a fertile area, structural realism, relational ontology. How do we think about that? I want to thank both of our speakers for lucid and clear talks and raising our expectations for the fruits of Madhyamaka meeting quantum physics one more level. Thank you both, and thank the questioners as well.
Thank you.
So with that, we come to an end to this session. I would like to thank our speakers and the chair for this highly enriching session and request them to take their place in the auditorium. Moving on to the next session of the day, for this session we have one speaker, Sri Mahan Maharaj from the Department of Mathematics, Arkim Vivekanand University, Belur Mott, Howrah. He will be speaking on the topic, the Algebra-geometry duality. As a chair for this session, we have Professor Shomok Ray Chaudhary, Director of the Inter-University Center for Astronomy and Astrophysics, Pune. So to begin with the second session of the day, I would like to request Sri Mahan Maharaj to come up and give his presentation. He'll be speaking on the topic, the algebra-geometry duality.
So, Your Holiness and friends, I must first start with an apology. I certainly don't know anything about Mula Madhyamaka Buddhism, except probably some smattering that I've read occasionally. And I barely know some physics which I've learned from my physicist friends. So the real reason why I'm here is selfish. I've admired His Holiness, the man and his work for a long time. So it's this sort of schoolboyish admiration. I just couldn't pass up this chance. Okay, so with this apology out of the way, I'll therefore proceed to share with you my ignorance of the subject. So the questions will be posed during the first half an hour, and hopefully during the next half an hour, we'll invite some answers from the audience. Okay, so the topic of the talk is the geometry algebra duality. So what do we sort of roughly mean by geometry? And this will, in some vague way, address a question that had come up during the question-answer session just prior to this. So anything we see, any shape that we see is sort of the subject of geometry. Yeah, abstracted out as a mathematical subject, that's geometry. What about algebra? Algebra originates with the notion of a number. So do you see number 1, 2, 3 somewhere outside? You don't. So for example, you can see one chair, one table, 2 people, but you don't see the number 2 anywhere. So what is common to 2 people, 2 chairs, 2 buildings, etc., is the notion of 2. This is called an equivalence relation. So that equivalence class is given a name. It's called 2. Behind all that, there's this human mind's capacity for abstraction. It sort of codes. So the number 2 is a name given to classes, each of which contains 2 objects. The objects themselves not being important. That's where algebra starts. And what is good about algebra is that you can formally manipulate symbols. And that's sort of where algebra starts. Okay. So now so that's sort of roughly where algebra starts and geometry starts. So where does the duality between them come into existence? And so suppose you take a geometric object, bounded geometric object in space, say, for example, a table. How are you going to capture the information, this visual geometric information of a table, in terms of algebra? So the way we sort of study even geometric objects, there is a geometric study of geometric objects and an algebraic study of geometric objects. So what's the geometric study of an object? You take some standard geometric objects, say, for example, a circle, an interval, or a string, and you map that into your space. Yeah? So essentially what you're doing is you're probing your given geometric object with some standard geometric object which you think you understand completely. For example, a circle. Okay? So that's the geometric study of a geometric object. Alternately, you could study it algebraically by considering maps, the space of maps, functions, from the geometric object, say the table, into an algebraic gadget that you understand. For example, the real line. Yeah? So you look at real functions on a geometric object, and then once you have functions, you can manipulate algebraically between them. You can add functions, multiply functions, perform algebraic operations between them. So the object as the target receiving object of maps from some standard geometric space, that is geometry, maps from the geometric object to the real line, this is algebra. Okay? There is a duality, so it's sort of, whether it's functioning as the domain or the range, this duality actually is the duality between geometry and algebra. Okay. So now let's look at the algebraic study of this table. So which means what? We shall consider functions from the table to the real line. Yeah? So one simple function that you can see is, so every point on the table is assigned a certain height above the platform. Okay? So that's a number. So every point is assigned a number. Its height from the level of the platform. Good. So now you look at all possible functions. So now the class of all possible functions, once you get, that has a certain algebraic structure. It's called a ring. A ring is something where you have addition and multiplication, and you have the function which assigns the number 1 to every point. That's called the unit function. That's the unit. It's a multiplicative identity. So it's some algebraic structure. You don't need to know the details. It's a ring. And so now once you have the ring, you can put it down on paper. You completely disregard, mathematicians have this completely disconcerting habit of forgetting the reality from where all these algebraic structures came from. And then if it does not fit the reality, well, so much the worse for reality. We are going to work with our what we have on paper. I mean, so we have this sort of somewhat disturbing habit, but we rather enjoy it, and we are going to go ahead, I mean, whether people like it or not. So you look at this algebra of functions, and now the question is posed that, now, okay, fine, so you've forgotten the table. Is the table somehow hidden in that algebra? This is the question. And the answer is yes. So you look at the algebra of functions. In this particular case, then there are certain sub-algebraic structures of the ring, so which are called ideals. I mean, so for example, look at all functions on the table which are 0 at a particular point. Yeah? So that's called an ideal in the ring of functions. That's an example of an ideal in the ring of functions. It's an example of what's called a maximal ideal. Again, technical terms, forget them. It's a fact, a theorem which says that if you have any maximal ideal in this ring of functions, that's actually got to be of this particular form. There has to be a point at which all these elements of the ideal actually vanish. So what does this process do? What it does is, corresponding to every maximal ideal in the ring of functions, these are both algebraic gadgets, the names are not important. So to every particular algebraic gadget, there's a point in the space. A point in a space is a geometric object. Okay? So a geometric object is being associated with an algebraic object. So therefore, the collection of all ideals in this ring of functions, that means the class of all sub-algebraic objects in this algebraic object are in one-to-one correspondence with the set of points in the geometric object. Okay? So you set up, from the pure algebra, you can recapture the geometry of the table that you started off with. This is a famous theorem from the 20s called the Gelfand-Naimark theorem. Okay? So this is sort of a prototypical theorem of duality between geometry and algebra. From the geometric object, you capture the algebra of functions. from the algebra functions, forgetting where it came from, you can recapture where it came from, recapture the geometric object, okay? So the visual way of looking at it and the algebraic way of formally manipulating things give you the same amount of information in this category. This is not special just to the Gelfand-Naimark theorem. These are continuous functions. There are more sophisticated versions of this, some of which actually predate Gelfand-Naimark, something called the Hilbert-Nullstellensatz. So you look at, say, geometric objects which are described by algebraic equations. So for example, x squared plus y squared equal to 1. That's a circle, right? In the two-dimensional plane, yeah? It's determined by some polynomial functions. Okay, so now you look at one of these geometric objects determined by algebraic equations, and you look at algebraic functions on this geometric object, on the circle. And a similar correspondence can be set up in terms of ideals, points, and what is called the sort of slightly soft geometry of that, which is called topology. So that is, again, there is an exact correspondence that's given by a theorem of Hilbert at the turn of the century, I mean, well, end of 1900s, early 20th century, called the Hilbert-Nullstellensatz. So that captures that particular information. So this geometry algebra duality goes on. Very recently, one of my sort of mathematical heroes, Misha Gromov, geometer, so he sort of makes this statement, and it's sort of this sort of poetic expression of this hope. He's at IHES France and Kurat. Anyway, so he says, makes the statement, descendants of algebraic kingdoms of high dimensions, enchanted by the magic of Thurston and Donaldson, two Fields medalists, geometers, lost in the whirlpools of the Ricci flow, topologists, class of geometers, dream of an ideal land of manifolds, perfect crystals of mathematical structure, which would capture our vague mental images of geometric spaces. So he's sort of expressing this hope, I mean, this sort of ongoing struggle that mathematicians have of, say, for example, I mean, very often we have to deal with spaces which have enormous number of dimensions, maybe 57, 26. I mean, how are you going to put it down? You can't see 26 dimensions here. That's a human limitation. So, but again, mathematicians are callous and they don't care about these human limitations. We would like to actually manipulate with these things. And therefore, what one has to do is sort of have a formal way, an algebraic way of describing these things so that the geometric structure is captured in terms of this algebra. Okay, so much for the algebra-geometry duality within the context of mathematics. And at this point, I'll sort of move into areas about which I know nothing. So how does this reflect in physics? And roughly, there are sort of two pillars of 20th century physics. One is relativity, one is quantum mechanics, quantum physics. So quantum physics has been elaborated on in this conference workshop, but relativity has been sort of short-shifted. And being a geometer, I mean, it's the part of physics that I probably feel greatest affinity towards. And it was one of these fundamental insights of Einstein that says that a distribution of mass in space actually determines and is determined by the geometry of the space. So finally, you don't need to think of mass as an independent entity, but you just need to think of the geometry of the underlying space. So space-time with a mass distribution is just space-time described with a Riemannian metric, okay? So that means the mathematical structure captures all of it, captures the entire mass distribution. So therefore, the field of relativity within physics is really the analog of geometry, okay, within physics. What about, and I would like to suggest that the mathematical tool that is probably most used in quantum physics, quantum field theory in particular, are representations of algebraic groups. So certain algebraic objects, representation theory, it's a very algebraic thing. So quantum field theory has to deal with a substantial amount of non-commutative algebra. So quantum physics has operators, observables. So operators, if you put all of them together, that forms an algebraic structure. So the entire amount of quantum theory may be captured
in a non-commutative version of this baby example that I gave. And now, very recent times, 97 or 98, a duality was proposed. I neither have the expertise nor the time to sort of dwell on this duality, but there's a duality that was proposed by a physicist called Maldacena, in string theorist, which talks about a specific kind of quantum field theory, a conformal field theory, on the boundary of a geometric space that several of us know and love, something called hyperbolic space. So there's or more precisely anti-de Sitter space. So there is a geometric space. Its boundary is one-dimensionless. Yeah. So it's sort of, if you have a 4-dimensional space-time or a 5-dimensional space-time, you have a 4-dimensional boundary on which you have a quantum field theory where you have some algebraic structure. The duality proposes that the physics captured by this quantum field theory on the boundary is the same as the physics captured by geometry, relativity in the interior. Okay? So the unification between geometry and algebra reflects in physics in pursuing what is probably the holy grail in theoretical physics today, which is to unify quantum theory with gravity. Yeah? So trying to get at a duality, a proposed duality between these two things reflects in this ADS-CFT correspondence. Okay, so having paid this little bit of lip service to the topic of the conference, I'd like to move on to the next topic, which is, again, this geometry algebra duality, in an area which I know His Holiness has been interested in for a while, and it's an interest which, again, for me, it sprang from some statements that Gromov had made. Okay, fine, so we are mathematicians, we do geometry, algebra, but how do we as individual mathematicians do mathematics, okay? And this brings us to the problem of human cognition. And the two senses that we use most in terms of geometry, for geometry, it's the visual sense, so the eye. For algebra, we need speech. So speech is sort of linearly ordered in time. You look at the sound symbols, they're sort of ordered in time. And you can manipulate them, construct sentences, parsing. All kinds of formal structures can be imposed there. The speech area of the brain is a much later evolute. Okay? So this formal structure sort of is what really can be put into the computer. You can put strings of symbols and they mean something. So how are we going to, so the geometry algebra duality reflected there, it's really asking for an algebraic description of the human vision process. Okay, so how do we recognize something geometrically to be explained in terms of the formal symbols of algebra? Okay, so there's a biologist, Stephen Malnick, sort of says that this model of human understanding is, so he puts it this way, it's despite being critical to human cognition, the study of attention and awareness, I'll dwell a little bit on these two words a little later, attention and awareness is amongst the most elusive of scientific endeavors, okay? So when we look at something, whatever is there in the visual field is what we are aware of. But then we have, as human beings, we have a capacity for focusing our attention on a particular gadget. So for example, this is called the party effect. You're in a party and there are lots of people talking, yeah? But you want to listen to what one chap is talking in the corner, and somehow or the other you direct your ear towards that person, and somehow the noise in the room is filtered out, and you sort of surrogately eavesdrop on what that guy is saying, yeah? So this process is a capacity that we have. So it's a focusing of the ear, right? So we can filter out noise, we can capture things. And really that is a large part of doing mathematics. We sort of forget inessential structure, try to zoom in on what the essential feature is and investigate it, yeah? That's probably a large part of scientific discovery is also based on that. We sort of decide what is the essential feature and shut out a lot of probably entropy, a lot of noise, yeah? So in order to understand human understanding,
I'll propose a toy problem, which I think at this stage we are really in I mean, it's probably a certain next step in some form of biology. So, so I'll sort of say a bit which I have learned again from some of my biologist friends. So let's focus not on human attention, human awareness, which is too vast, but look at just visual attention, visual awareness. Okay? So two biologists, Hubel and Wiesel, somewhere in the 50s, they conducted some path-breaking experiments. And so the way the eye perceives motion, yeah? So there's something that I see in front of me, and then it moves. Whether it moves from one point to the right, left, up, down, is something the eye can sense. How does it do it? It's that every cell in our retina has a certain field of awareness. The next cell also has a field of awareness. It's comparing these two signals to see which one becomes more intense that decides the direction of motion. Yeah? So this is vaguely the model that was proposed. It's being checked. What is motion? Motion is in time. So it's, again, an ordering of symbols, yeah, in time that is recorded by the eye. But what about shapes? What about geometry and how it is recognized by the eye? And so following up from Hubel and Wiesel, I was able to find a couple of biologists, Bischoff and Demion. So they speak of this ventral object recognition pathway, which was what they're really trying to do is ask this question: when we see a thing and recognize something, which process are we following? Are we following the algebraic process? Are we following the geometric process? Let me elaborate this a little bit. What is the algebraic process? So suppose, so they performed this experiment. It's every child actually plays this game. It's called Where's Waldo? Where's Waldo? Say you have this picture book, you have a scenery, and inside the scenery you have hidden little teddy bears in various places, okay? And so you have to find how many teddy bears are there in your little picture. So the kid sort of trains his eyes that way. To train a computer to do that is very hard. So actually computers are far more stupid than a young human baby, in this particular aspect. So what does it do? We sort of try to these biologists try to do the following. Say, you take that teddy bear, and then you start looking at your big picture, and you start scanning, okay? This is really what the computer does. It takes this big picture, it converts it into one long line, takes the teddy bear in hand, goes to the beginning of the tape, and then just walks stupidly along this long tape, and wherever it finds the teddy bear, it said, okay, got one, got another. It's a very reliable system, but it's a long time consuming thing. This process is followed by the human eye, but that's not all. What is the other thing? So this algebraic way is one way. So this is linearly, it's time ordered, so I would call it algebraic. The other process is to take in the whole picture at one shot, isolate certain features of the teddy bear, say for example its color, its shape, face, certain facets, and then zoom in at random in various parts of that. So that will need this focusing of attention. And then say that, okay, so there's going to be a teddy bear here. It might not capture everything, might not capture all the teddy bears, but there's a good chance that it will capture many of the teddy bears in a much shorter period of time. This actually sort of reflects and shows that in the human eye, there's a lot of parallel processing going on. Yeah? So it's sort of taking several patterns, matching all of them simultaneously in terms of what we are recognizing. Yeah? And this parallel processing part of the eye, I'm using the word parallel processing because it's terminology borrowed from computers. If we can somehow train the computer to focus its attention, that's really what is required. Yeah? And really, there is no computer model for focusing attention. So I would say that if one can convert it into some kind of parallel processing model, that would probably be a major breakthrough in sort of recognizing pictures, pattern recognition at the next stage. Why would that be important? Because if we have an understanding of even this toy model of how the human eye, the baby human eye, recognizes a pattern lost in a picture, then perhaps that could serve as a model for human comprehension, uncovering mathematical structures in a panorama of mathematics which is there as a scenery in front of us. Okay, so I'll stop there. Yeah.
Thanks very much, Mohan. I mean, before inviting questions and getting on to discussion, I thought I'd actually summarize a couple of points which came together in this presentation. One of the things, of course, is that we are somehow, we have used the word duality in many ways in this, even in this meeting. And from the talk of Professor Sarukai this morning, and now, it seems that we have now converged on a version, or our physics mathematics version of duality, that has this fourfold symmetry that Professor Sarukai said this morning. And then it's in this sense that today this word duality was used. Because to some extent we are looking at two different ways of looking at the same thing, but you really can't do one without the other. And that is how this whole point of algebra and geometry came together. It was wonderful the way Professor Mohan Maharaj actually talked about how algebra, in terms of quantum theory, is now wants to explore this duality with geometry in the form of gravity. And this is, of course, as you know, the 100th year of general relativity, of the description of exactly 100 years ago, Einstein came up with this path-breaking description of gravity in terms of the geometry of space-time, as opposed to what we believed before, or physics worked with before, and that is gravity in terms of forces and algebraic expressions. And so the fact that we have a geometrical view of looking at something with which the same thing that we looked at from an algebraic point of view, gives us a clue that later on, when we look at the synergy between the various parts of physics, we would look at a duality of the algebraic aspects of things and the geometric aspects of things. And this is where the ADS-CFT idea comes from. And if you have any questions, do take part in discussion. The second part, I thought the concepts that came together are these large-scale features that one sees in vision, and the small-scale features. And so the idea is that you can't do one without the other. I mean, one of the basic things in image processing, for example, people who have worked in practical aspects of image processing know that any image, visual or otherwise, taken by a camera at any given, any definition of an image whatsoever, has small-scale features and has large-scale features. And we now are so used to manipulating images on our computers, in our phones, that we kind of forget the history of the way these things have evolved and the way we look at an image. I mean, for example, you have a filter called unsharp masking in your little, in any computer program nowadays, where what you can do is you can get rid of or try to model out the large-scale features in an image by subtracting them out, and thus highlighting the small-scale detail of an image. And this was, of course, it has a long history and came from the recognition that one can, to some extent, separate out the two. But if you, for example, want to blur an image by making the large-scale features more apparent, it is very difficult to completely take out the small-scale parts of the image as well. So there are various tricks to do that. But the idea is that any image is a combination of the small-scale features and the large-scale features. And the brain works out ways of perceiving these things, both in a visual image and, of course, in a sound image, as we heard before in the cocktail party problem, where we know that we can train ourselves in a room where there are many conversations going on to focus on certain conversations and then somehow average over the other parts of the conversation. So it's very interesting that when we look at the synergy between quantum theory and gravity, we're looking at a duality that is of the same nature as the kind of problems that we're talking about in visual
or even sound perception. So I would throw this now open to the to everybody here. Do you have questions for the speaker? There are mics around, right? Professor Nityananda.
I wanted to ask whether this has any connection with left and right hemisphere that we care about in the context of neuroscience.
I have to confess my near complete ignorance of biology, so I have no idea. I'm sorry.
But we've all been exposed to this idea that the left hemisphere has this concept of time, is more algebraic, and the right one sort of takes in geometry. So I thought you couldn't resist.
No, so I didn't have that in mind at all. So, this whole thing was sparked off by a conversation. I mean, the biology thing was sparked off by a conversation with Shubha Tule. She's a biologist, and so she sort of told me various things, and then I read up. And so, I did not think of the left-right hemisphere.
Is there anybody in the audience who would like to make a comment on this?
It's not on that topic. I had a question. Should I go ahead with the question? You know, in some way I'm trying to connect this also back to the Madhyamaka presentation we heard. It seems like what you're driving at is that there are certain manners or ways of conceptually designating. So for example, take the very end when you were speaking about finding Waldo. And there's a way in which we can analyze that problem, which is quite linear. I think you called it algebraic in character, right? And that's a habit or a way of looking, of conceptually designating, of labeling, right, sorting. And then you're saying, but there probably is also another way that is really more holistically conceived. You use the word parallel processing. And to me, it reminded me of the relationship between the Turing model of computation and the new universal quantum computer, where you actually work with what is called quantum holism or quantum parallelism, which allows you to not go in a linear way that you were speaking about, but in a more holistic way.
Yeah. So, so we are on the same page. But the thing is, we are sort of using different words because of different backgrounds. But I think the hard scientific problem right now is to develop an actual scientific model. So that's why I use the word parallel processing, because that's sort of closest to the computer terminology. Regarding the philosophical point, I'm sort of vaguely aware that in certain philosophical traditions, the visual image and so the visual way of seeing comprehension and the auditory way of seeing and of hearing and comprehension, once they get synthesized in one way, so sort of what one hears and what one sees is the same. This comprehension is called pragya in certain traditions. Okay? It's wisdom. So.
Pranam Maharaj. I had a different question. I'm a physicist by training, and so suppose I look at that water bottle and I see it as water, but then with a very powerful microscope, I know that, okay, I can see the hydrogen and oxygen atoms and making the water. If I have a more powerful microscope, I can go to the subparticles as well. Now, if my eye was so powerful that I could go to that lens scale, my whole view of the world would change. And then the things which we are debating now, many of the questions would actually be disappearing.
We would be debating different questions then.
Exactly.
So I think the way the eye has evolved, it's taken millions of years for the eye to evolve, right? So what started off was actually a certain part, it's apparently, so what I believe is that the retina is still a part of the central nervous system. I hope there aren't too many specialist biologists in the audience. They'll catch me out on this. The thing is, it's a certain part of the tissue that becomes photosensitive because, and one sort of curious, it's not curious, it's sort of perhaps, perhaps there will be a deeper scientific explanation for that. It's just that our eye is most sensitive to the wavelengths that are emitted by the sun. I mean, where there's a peak in the sun's radiation is precisely, I mean, so the eye has evolved in order to be sensitive to precisely that range. And that is sort of partitioned into various colors and so on. Yeah? So, I mean, it's a certain degree of evolution which, I mean, it's not a theoretical science investigation that makes the eye evolve. I mean, it's much more tangible. I mean, we need to survive, eat food and carry on, right? I mean, so it's, yeah, I mean, so much more fundamental things have led to the evolution of the eye. So if there are such biological factors which will require the eye to evolve more, perhaps it will. So, yeah, yeah.
Again, since the evolutionary aspect was raised, I think it's worth pondering a very important aspect of our vision, and that is that, of course, our vision responds to the basic threats that that are posed to humans. Because you look at the variation of levels of vision in the animal kingdom, insects, etc. Visions are very different. I mean, the way even the time resolution is different, the wavelength coverage is different. One very important aspect of vision is that if you look at the atmosphere, that the entire electromagnetic spectrum, there are only two places in the electromagnetic spectrum that the atmosphere actually lets through light from outside the atmosphere. And that is a very narrow range between 400 and 800 nanometers, which we call blue to red. And then there is a little window in the radio, and that's it. And of course, none of the other bits of electromagnetic radiation come through the atmosphere: ultraviolet, X-ray, gamma ray, infrared, etc. And lo and behold, our eyes are tuned to just that window. We see just the bit that comes through. And that is why, if we, for example, were tuned to the infrared part of the spectrum, we wouldn't know the existence of the universe outside our atmosphere. You know, I'm told rattlesnakes are sensitive to infrared, and that's why there are no rattlesnake astronomers, right? So the idea is that we are, so that is a very interesting part of not just the time resolution, but the way we see things. It's also that, you know, our vision. And so I'm sure the resolution with which we see things, and also the information that come from a visual, you know, a certain object, is actually geared towards a long evolution of our species, and that is a very interesting thing to ponder upon. Any other questions? Yes.
Yeah, I have a question. Am I be right in saying that we register what we want to register, and that depends on the relative biases or prejudices we carry? For example, here we have taken the example of human eye, but then animals also have eyes. And then it is not just the mental, so we talk about mental imprints. So mental imprints are not just the visual imprints, they are auditory imprints, they are olfactory imprints. So there can be a blind animal which can recognize events through smell, or there can be like bats who have. So my question is that the way we process information through senses, does that depend relatively on the prejudices or the person we carry?
I prefer not to use that terminology because that terminology is sort of loaded. I mean, so, for example, evolution. This is not. It's working. Yeah. Oh, okay. Yeah. So, so the point is, if you use the word prejudice in a much larger context, evolution prejudices us. I mean, so certain tortoises developed long necks because they wanted to eat more leaves. So will you call that a prejudice, really? I mean, if you call that a prejudice, then I'm willing to accept that. But typically, I mean, it's a bias, right? Yeah. So bias is determined by various external factors. A species wants to continue itself. This is the fundamental reason why certain evolutionary features emerged. I mean, some things become sort of blips in evolution and they die out fast because they have no use. But then certain changes in the genetic structure turn out to be beneficial to the species that survives. So I wouldn't say prejudices, I would say biased by evolution. Yeah?
So so thanks for correcting me. But then, so that means that individual register what, as per their biases, what they want to register. That means the reality they see through these imprints that they carry is actually the registering of the events as per their biases, which is not the absolute reality, but in relation to the environment or the biases they have been groomed into or they are living in. So that means, coming back to the Madhyamaka view, that this is also relative. If I say that the experiences...
See, the thing is, I mean, we are really, again, mixing two paradigms here completely. Yeah, one is a very human, day-to-day level of so for example, I mean, will you say, looking at this bottle, as a bottle, is it dependent on individuals' biases, prejudices? Or would you regard it as an objective fact? Science proceeds by, okay, fine, this is a certain piece of datum which is common to all of us. So we abstract out that that sensory capacity which is common to all of us, we say is without bias. Okay? So this we have to, by our limitations, we have to use human terminology, right? But then on the other hand, when we interact with another individual, I might like somebody and might not like somebody else. That you can call prejudice, but for that we don't have a scientific model, right? So, I mean, if we use words like prejudice, bias, and then translate it into a scientific context, I think we are really sort of playing with words. Yeah, I mean, it's not going to help me get rid of my biases in dealing with other people by sort of trying to understand how I look at this bottle.
Thank you, sir. Maybe I should have used the word
so for example, I mean, I think one of the great, very good physicists alive today, I won't mention his name, he says, you don't need to use quantum mechanics to understand how an umbrella opens.
Thank you, Mahan.
Professor Panchapakeshan, I'll come back to you.
You said that the computer cannot focus attention on a particular point.
I'm saying that, what I'm saying is that this focusing of attention, that's a feature of the human mind, human eye in general. It's not got an adequate computer model till date.
No,
adequate.
I'm a bit surprised because pattern recognition has progressed
yes.
tremendously.
So, absolutely true. Absolutely true.
And so, I heard, for example, that the brain wave, if you think of a word A, the computer can recognize that brain wave and print the letter A just by after several trials. So I'm surprised that pattern recognition cannot be applied to this.
No, so that's right. So pattern recognition is what I was talking about. So pattern recognition has these two aspects to it. One is this linear way of scanning and determining. So that pattern recognition does happen. Recognizing edges, recognizing motion to some extent, it does occur in pattern recognition. So pattern recognition is at that point at this stage. What it does not have is this extra bit of parallel processing. So this is really a problem for pattern recognition. I mean, I would hope that it is one of the next steps that pattern recognition takes. In that case, we'll develop a model, a computer model, for how the eye focuses its attention.
There's a question there.
Thank you, Mahan, for your wonderful presentation and a wonderful action. Let me ask you, as you mentioned, the algebra mathematics is the most important language of quantum mechanics. Yes, I agree. So this question is a little bit different what we have subject here. But please, you can choose. This is maybe you are difficult to say what you have really feeling. But I must ask, mathematically, in quantum mechanical level, did you feel there's a very important theory, indeterministic? Indeterminism. Indeterminism and uncertainty principle.
Yeah.
Those theories, did you feel contradict the creator, theory of a creator, or internal creator?
Oh boy. Again, I mean, I would prefer to keep these two. I mean, I think that part is, I think His Holiness sort of says it in a very nice way. It's a personal taste, we leave it there.
Are there any questions from the first half of the talk? I mean, can I have any questions from the back of the audience? I mean, there are lots of students here, young people hearing. Anybody want to ask a question?
Hello. Thank you so much for the lovely talk. This is a question, more than a question, this is like a comment. So when we look at something, before we see a bottle, we see the bottle first, but what it evokes is an emotion. So when I say, see a water bottle there, maybe I've had water from a similar bottle with my parents back somewhere. Yeah. And that is what creates this, which creates this question of duality of thought, what we see versus thought, what we perceive.
Yeah.
And I would like to know, how would you relate this to just geometry? Like,
no. So see, there's sort of two different things again. I mean, let's sort of again separate out two things. One is the image of the bottle. Yeah. So if you are not feeling particularly thirsty at the moment and the water is clear and all these sort of standard factors are taken care of, it's just going to, okay, it's a bottle, that's it, right? On the other hand, if you are feeling thirsty, oh, I wish I could get that bottle, right? So there's some kind of human emotion coming in at that stage. On the whole, when we look at a thing without coveting it or without sort of repelling it, you're just neutrally recognizing an object in the external world. That is cognition. The second part is where your emotions come in. That part I am not considering as part of this geometry algebra duality. I mean, the very substantial part of the mathematical enterprise is to sort of prove what is true, not what we like to be true. Okay?
So can we say that our vision...
And I mean, see, the thing is, as mathematicians, we've had our intuition thrashed solidly so many times that we are all very apprehensive. I mean, a part of the mathematical training is to have an inbuilt skeptic which keeps doubting everything that we say. I mean, whether we are saying what we are saying is true or not. It's a tremendous safeguard about making sort of very large-scale assertions. Okay, this is all that we can say. About the interpretation, etc., that's a different man's job. Yeah. Maybe the same man, but not with the cap as a mathematician.
Anybody else? Question?
So my question is about, we were talking about geometry, and you mentioned that through algebra, like if we have a universal set of functions, then we can go back to the object.
That's right.
So is it entirely possible that through the algebra, we could perhaps perceive certain higher dimensions, which are not apparent to us?
Absolutely possible. Absolutely. I mean, it's not only possible, it's done. I mean,
but
we
wouldn't
do
that
it for a
contradict
living.
our current cognition? I mean, how would we understand it? Because we cannot physically intuit it, as you mentioned.
No,
So
okay.
how would we develop an understanding?
Just a moment.
Yeah.
So I would suggest, I've forgotten the reference for this, how to visualize 4 dimensions or something like that. Article by William P. Thurston. Thurston, yeah?
William P. Thurston.
Thurston, yeah? So he's a Fields medalist, and I mean, the field of geometry that I work in, he sort of founded, okay? And the man's intuition, visualization capacity far surpasses any human being's visualization capacities I've seen. And definitely he can perceive things in dimensions 4, and he sort of tells you the tricks of the trade, how he sort of trained himself in visualizing things. I'll tell you a very simple trick. So, for example, I mean, how do you say, suppose we were 2-dimensional creatures, how would we perceive 3 dimensions? You take a circle evolving in time, yeah? So a movie of a circle moving, right? That would give rise to what? A sphere. So you start off with a point, the point becomes a small circle, it becomes a large circle, and then starts becoming small again and becomes a point. Now you take that time and make it into a space dimension. What do you see? In this x-axis, the point, it becomes a circle and it closes down. So in 3 dimensions, you're seeing a sphere. So now you look at a sphere evolving in time, right? So you'll be able to perceive in 4 dimensions. You'll have to train yourself to do this.
Yeah. Okay. Thank you.
Are there any other questions, comments from the front rows? Back again.
The last point that you mentioned, is that opposite of compactification? Because like the opposite
Oh,
we
no,
do.
no. This is what I'm saying is something fairly naive. It's called it's a duality. It's something called the duality between dynamical way of looking at it and geometric way of looking at it. Say if you have a dynamical system, it evolves in time, right? So if you can think of evolution in time where time is a distinguished direction. That's the viewpoint of relativity. But if you think, for a mathematician, the time and space don't have any distinct things except in the field of, if you are thinking of it dynamically, then there's this extra dimension in which it's evolving. But if you take that extra dimension, forget it's distinguished, right? Then what are you doing? You are looking at geometry in one higher dimension, right? So geometry in one higher dimension and dynamics in one lower dimension are the same. The correspondence between that is what this is. This is sort of a toy example of this.
If there are no other questions, let's submit to something more primal. Everybody's hungry. Lunch is ready. Thank you very much for listening. Thank you very much, Mohan, for your wonderful talk, and for His Holiness for his patience. Thank you. Bye.